All right, let's start off with, again, the problem. What are sort of some of the challenges today here? The problem we're going to be talking about and potential solution is actually there's way too many tools out there around supply chain security. And this is a good thing on its face, but it can lead to a lot of issues. So here are just a list of like probably less than 1% of the security and supply chain tools that have been released over the almost past 2 decades. And as you can see, there's just a whole ton of them there. And there is kind of there is very much a focus on how can you adopt all of these. And that can be a huge challenge, right? Because you're expecting developers to know everything. All right, and so the burden, right? It falls on developers. There's a lot to adopt, right? There was a 2034 global DevSecOps report. You have a lot of tools being asked to integrate more and more tools into your ecosystem, into your build processes, into your SDLCs. Also, poor integration slows teams, right? Another recent Veracode report said that the amount of time it's taking to fix vulnerabilities is actually tending to increase, which is a huge problem. And with all the stuff that we're kind of being asked to do on a day-to-day basis, we have adoption fatigue. And then in addition to all these tools, right, we're being asked to do all sorts of things with actual practices. We have things like, 2-person code review, having a centralized build service, doing ephemeral builds. And this survey that came from Salsa here, it shows pretty reasonable results, but also this is a Salsa survey, so most of the people who probably responded to it are folks who are already doing lots of good supply chain security stuff in the first place. And so we need something like a Kubernetes control plane, right? Because Kubernetes did this for the cloud, right? You had all these different processes, all these different things you needed to do to manage containers. And how can I do this simply? Well, use Kubernetes, right? And you have things like Kubernetes, right, where you have controllers which help reconcile state and manage the cluster. You have etcd, which stores the state of everything that's going on in the cluster. You have the Kube API server, which validates and configures objects. You have the schedulers, which schedule, and you have the control manager, which is kind of the overall control loop of Kubernetes. And so Kubernetes introduces abstractions, which can help with that complexity. And so you have things like various different nouns and verbs that Kubernetes uses to manage container-based workloads mostly. And can we apply this to the supply chain? Well, let's take a look. Here is sort of an example SDLC, right? You have a project running on a workstation, which gets pushed out to Git, which gets pushed out to eventually to the build system. The build system runs the build, it publishes the artifact, eventually gets deployed, and then eventually it's in the runtime system. And each system and each phase is a place that needs to be controlled, right? Each one of these things needs to be controlled, and then also in addition to that, you need to think about the whole thing holistically, right? Because something in the middle can break and then cause issues. And we need controllers, state, all of these different things inside the SDLC as well. And our SDLCs look more like Mesosphere than they do Kubernetes, if folks are familiar with Mesosphere. Pretty much the thing here is everybody handles their SDLC differently. Currently it's not like Kubernetes and OCI and containers. It's more like just a disparate set of things that are going on. Okay, so we need AStRA. And I'll hand it over to Eman to talk about how that might fix things.
So what about software supply chains? Maybe we need AStRA. So as a first step to form a SDLC control plane, we need the same concept of abstractions that Kubernetes used. So as they use these concepts to reason about a cloud workflow, we need similar concepts to talk about software supply chains. And here we introduce AStRA framework. AStRA framework defines such abstractions for the software supply chain. We model software supply chains as direct acyclic graph by capturing the core elements in any software supply chains, which are 4 elements, and their causal relationships. Elements in this graph are nodes, and the relationships between them are the edges. Let's start by AStRA nodes. AStRA nodes are the 4 core elements in any supply chain. These are artifacts, steps, resources, and actors. Let's start by artifacts. It answers the question what was consumed and produced in a software supply chain. This can be actual software like source code, package, container image, or can be metadata like SPOM, into attestations, or build logs. Then we have steps, which answer the what question, what happened in the software supply chain. This can be course steps like build, test, or find steps just like a commit in GitHub to add a README. Then we have resources, which answers the where question, where did this happen? For example, in a Git, GitHub actions, or which OS was used. Then we have actors, which answers who was involved in the software supply chain steps. This can be developers, organizations, even bots. Now let's talk about AStRA relationships. AStRA captures 3 types of causal relationships between the 4 core elements in a software supply chain. Where the first relationship is that actors identified by their credential use resources. Here, a developer uses, for example, a version control system. Then we have the second causal relationship, which is resources carry out steps. In the same example, the version control system carry out a git commit step. Then we have steps consumes and produces the artifact. For example, takes a source file and git repo can consume it and produce a git repo at T+1 of the time. This forms the topology concept, the AStRA topology. Here, which will help in reasoning about the transitivity in the software supply chain. Supply chains can get very complex, and of course, it's not just one step. So, for example, we can have a software supply chain that has a source step where a developer uses Git to carry out a commit. This is the sourcing step, which will produce the Git repo at T+1. Then after sourcing, we have a building step. For example, it uses GitHub Actions and consumes the same Git repo and produces an artifact. Then we have a packaging step, which will uses NPM, for example, to consume this artifact and package it into a software package.
Yep, and to real quickly, there's a lot here. These are a lot of the tools that are being used today for software supply chain security. If we start to sort of use those, if we start to have those tools speak that AStRA language, right? Salsa, hey, it contains where an artifact, what artifact was built, what were the steps to build that artifact, and so on. We can then have that be used to become part of an eventual control plane, which then leads us to the takeaways here, right? Development of an SDLC control plane is extremely early. We need more ideas and prototypes. Come join us and chat after this, because we'd like to bring it to groups like the OpenSSF and see if there's interest into building this, into sort of getting folks to take AStRA and make it part of the sort of way we communicate about software supply chain security. Thank you.
Okay, very short question. How hard will it be to implement this for AI? Because going from step T to step T+1 is very similar to like fine-tuning a model or updating a data set, cleaning up the data set from one step to the other.
I couldn't hear you well. Can you?
Okay, so how hard will it be to implement this framework to the AI world? Because cleaning a data set is moving from step T to step T plus 1. Fine-tuning a model is again moving from situation at step T to the situation at step T plus 1.
Oh, actually, we're still like in like an early state of the project. We have not like started implementation yet. So, what do you think?
So I think it probably would work for AI, just because AI, like anything else, is just probably like a normal supply chain. As long as you can sort of codify those steps, I don't see why that it wouldn't apply to it.